Okay, so now let's talk about what they observed. Recognize people do not know at this moment about photons. They still think light is just a wave traveling forward. Okay, that's what they know. So this is what they were observing. Number one, so as good experimentalists, what do you think they did? Well, the first thing they noticed was there was some sparking going on. So the logical explanation is, why don't I just test it with different colored lights? So I have red, I have blue, I have green filters, I have all of these kinds of filters and all of these kinds of lights that I can use. So they use those. The other thing is, can I change the intensity of my light that's incident on it? And so they did. So they took red light and they changed the intensity of it. They took blue light, they changed the intensity of it. They took green light, they changed the intensity of it. And this is what they observed. Number one, change frequency of light. Basically the color of light. So the three I'm going to pick are red, green, blue. Everybody okay with that? Okay. So here's my metal. And I'm going to shine a red light onto it. And then they saw whether electrons were emitted. And let's say my answer to number one is no. Then they said, okay, well, next color would be my green color. Electrons emitted, the answer is yes. But they saw that they had lower speeds, which means low kinetic energy. And then they did blue. Keep the amplitude the same as much as you guys can. The height, keep the height of the light as much as you can the same. So we're not changing amplitudes yet. And they saw, so this is experimentally, they saw yes, with higher speed, which means higher kinetic energy. So as frequency increased, that's what they observed. So now that the red is not emitting anything, they said, why don't we take all of these lights and increase their intensities? Okay, so I'm now going to take the red light. So same metal surface, but I'm going to change its amplitude. Lower amplitude, higher amplitude, even higher amplitude. Are electrons emitted on the other side? Nope, nope, nope. No matter how much I increase the amplitude, no electrons were emitted. Now let's try it with the blue. Okay. What do you predict will happen? What will happen to its kinetic energy? Hold on, don't say it. So first of all, let's see whether the electrons were emitted or not. And then we'll see what happens to its kinetic energy. So the first blue one, low amplitude blue, higher amplitude blue, and even higher amplitude blue. Just, you get the picture, right? Increase amplitude. Will electrons be emitted? Yes, good. Okay, so same metal, electrons emitted. What do you think happens to the kinetic energy as it goes down? What does classical physics say should happen? What happened here? Lower speeds, low kinetic energy, higher speeds, higher kinetic energy. Now I'm increasing the number of electrons that are incident on it. Should that translate to higher kinetic energy? That's what classical physics predicted. That's what they were expecting. But what they actually found was that the kinetic energies remain exactly the same, no matter how much we increased its amplitude. So they didn't get any faster. And so what they found was very strange for the time, because they were just used to looking at intensity as power per unit area, right? Watts per meter squared. The more intense, the more wattage per meter squared, the more intensity it's going to be, right? The more things will come out. That's not what they observed. So this is their experimental observation. So classical physics cannot explain this. Number one, no electrons are emitted until a particular frequency is reached. Number two, the particular frequency depends on the metal. And number three, the kinetic energies of emitted electrons are, number one, so they're independent of light intensity, and number two, increase with frequency of light. So as I increase the frequency of light, the ejected electrons are coming out faster and faster. So the red will be the lowest, then green, then blue, right? These are the ones we were using. That's what they saw.